Hello? Is this on? Yes. Hi, everybody. A quick administrative note. For those trying to connect to Wi-Fi, please pick AT&T Wi-Fi. That one will get you through a click-through, so you don't need OSU credentials to connect to it. All right, so let's get started. Today's second panel is Data-Driven Understandings of Society. My name is Arnab Nandi. I'm a professor at the Computer Science Department at Ohio State. And we have with us Eitan Adar, who is a professor in the School of Information and Computer Science at the University of Michigan. We have Pankaj Gupta, who is joining us from Twitter, where he's the team lead of personalization and recommender systems. We have Tara Peder, who is the AVP of IT architecture at Nationwide Insurance down the road. So the format today will be, we'll have Pankaj go first, followed by Eitan, followed by Tara, and we'll be talking about different aspects of how we perceive data and how we can use that to leverage information for decisions and managing society, so to speak. And so I like that there is an academic in the house, and there is a person from the business side and someone who's also dealing with the communication media. So let's get started.
Hello. Good morning, everyone. I'm going to start with a small video clip that is just an introduction to Twitter. And the person talking in the beginning is Biz Stone, one of the founders of Twitter.
It's such a simple tool, yet people have done so many amazing things with it.
Suspect in custody, but nobody inside the perimeter.
You're able to have these multi-directional conversations. You're not just broadcasting, you're there in the middle of it.
I am going to make history here as the first president to live tweet.
I'm using Twitter to send pictures and thoughts from space. And every day, I really enjoy reading your tweets.
There's an incredible leveling of the playing field that gives every voice the ability to echo around the world instantly. And that democratization of content creation and sharing facilitates these connections that we see every day around the world that we would have never seen before. The possibilities and the opportunities afforded by the platform are limitless.
So the theme of that video clip was just precisely this, that Twitter represents the pulse of global society. And this panel being about data-driven understandings of society, I'm going to be giving just a few examples of how Twitter data has been used and is being used for understanding society and hopefully impacting it as well. Now, in order to support that theme, there's just some numbers here. As the video showed, there are 500 million tweets sent every day. And that implies there have been more than 300 billion tweets that have been sent since the first tweet was sent. Twitter is a global phenomenon. It is tweets are sent in over 35 different languages and from nearly all countries of the world. We have more than 240 million monthly active accounts, and 77% of those accounts are outside the US. And we like to call Twitter as a public global town square. And the biggest implication of having such a public global town square is this, that we have fine-grained data about user behavior in real time at an unprecedented scale. And I'll come to this, just the single observation again and again throughout this talk. Well, so with that as background, there are two questions that I want to kind of touch upon broadly in this talk. One is, how can we understand society better through Twitter? And second, Twitter brings new data, and how can this new data have any impact beyond understanding and beyond observational analysis of society? So using Twitter data to understand society, so let's dive into the first. Well, So one thing that Twitter helps us understand is that this global society is a lot more interested in Oscars and selfies by Hollywood stars than they're interested in politics. For those who have not seen this before, the tweet on the left was a selfie pic taken during Oscars, and it broke all records. It was shared more than 3.4 million times as of last night. And it broke the previous record of the picture that was sent on the right, the tweet that was sent by President Obama after his re-election. And that was the previous record, less than 1/4 of the shares since November 2012. But seriously, Twitter data is much more useful than looking at statistics of selfie tweets by stars, and in particular, understanding cultures and customs across different countries. And while looking at this presentation, while preparing for this, I literally came upon hundreds of examples, and I just want to highlight 3 of them. The first example is a study on the rhythms of life done by my colleagues at Twitter, Miguel Rios and Jimmy Lin. What they did was they studied the tweeting activity of 50 cities throughout the world and observed a variety of patterns in them. Just to give an example, there's one type of synchrony that they call as the routine synchrony of the daily routines. And here, this graph is showing the tweeting activity of tweets that say good morning across 4 different cities, or Buenos Dias and Madrid. And this is just showing, the y-axis is just the number of tweets that is sent containing that phrase, and it's just the morning hours. And it's a really simple graph which shows a few things, and just to highlight what kinds of things we can see using Twitter data. The blue curve is weekday, and the orange curve is the weekend. And one thing that you see is that generally different cities kind of wake up at generally the same times, both on the weekdays and weekends. You see that there is a gap between weekday peak and weekend peaks. People like to sleep in during weekends, and that gap is highest in Madrid, and not as much in the remaining 3 cities. An even more interesting part of their study was to study what they called as cultural synchrony, which was a deeper study of 8 different cities throughout the world. What they did was they built heat maps, again, of tweeting activity for every minute of 2012. So this is all the tweets going on from that city. And what kind of patterns can we detect by just looking at this heat map? So I'm going to take 3 of these cities and see what kind of patterns we can detect. So this is tweeting activity in New York. Again, this is a heat map. The lighter the shading is means there are fewer tweets at that time. The x-axis here are the months of the year, going from January to December. And the y-axis is the hour of the day, starting from 0, which is midnight, and then going to the night. And this is noon, it's 12th hour, and then going into the night here. So what are the things that you can kind of observe from this? And this is pure observational analysis. You can see that, well, it's very light during the night, as you can expect. And then you can see a few patterns. You see some stripes here. Well, what are these stripes? Well, this is just the weekday versus weekend. During the weekday, people are tweeting less during working hours, and that's not the case during weekend. Another example of the behavior that you can see is that behavior actually vanishes during the evenings. People are kind of consistently tweeting during the evenings on both weekday and weekends. So that's the daily and the weekly cycle. And then there's the yearly cycle as well, and that's highlighted here. Well, what's going on here? Why are people tweeting kind of well past midnight in this area? Any guesses? Yes, it's summer. People are, staying up past midnight, and so they're tweeting at that time. If you compare that to Tokyo, those patterns are almost completely absent, and that, casts some light into the differences between the cities. There is some weekday weekend patterns, but nowhere as pronounced as in New York. And the final heat map that I want to show is Riyadh in Saudi Arabia, which is one of the most interesting ones. And there's many patterns here. First of all, this whole heat map looks completely different than New York City or Tokyo. But one of the most interesting one is this anomaly during this time. And what Jimmy and Miguel, my colleagues, found was that this represented the month of Ramadan, during which people fast from dawn to dusk. And so this is kind of going into the sunset hours, and people were clearly not tweeting when they're hungry or just when they're, breaking their fast. So moving on, my second example is how do we understand national cultures literally? And this is a study published by external researchers, so not Twitter people, but using Twitter data, on studying cultural dimensions in Twitter, published last year in ICWSM. And what they did was this was the goal of the study. They said, well, a lot of researchers have previously studied using questionnaires and direct measurements, variations across national cultures, and measured, and they have developed various indices. And they talked about 3 indices in the paper. One is just something that measures the pace of life, and it shows it is what it seems, what it intuitively means, that it represents things like punctuality, just how fast you walk, and things like that. Then individualism versus collectivism, so how many of your friends are beyond your immediate family. And the power distance index, which is a measure of how much people expect or even accept inequalities in power. So the goal of their study was, well, so questionnaires and direct measurements can give us these scores in different countries, and can such variations be detected by online activity data? And they found yes. So for example, they found that high pace of life was correlated with higher predictability of sending tweets, which is what you would expect as well. There's a lower entropy, lower variation in when people send tweets in countries with higher pace of life, like Germany, Sweden, and so on. And there's a lower fraction of users tweeting during the waking hours in those countries. Then they also found that less individualistic countries, so more collectivist countries like Indonesia and Brazil, had much higher interactions, which is shown in the y-axis. And that was true throughout the day than countries like UK, USA, and Canada. These are interactions on Twitter. And finally, they studied some network properties as well, in particular the in-degree imbalance between the source and destination of a follow edge. And they found that users tend to follow more popular users in countries with bigger power distance index, with bigger inequality. And they say that these are interesting because all these social measures are actually highly correlated with other socioeconomic measures of GDP and education expenditures, and so on. My final example is something which is unique to Twitter. With Twitter, with the data publicly available, now you can measure the reaction of society in real time. And there's a visualization that the Twitter data visualization team did during the State of the Union address this year that I can do a live demo here. So this is let me explain what this visualization is. This is showing the speech, President's speech, and you can scroll through these paragraphs, and as you scroll, you will see what people are tweeting about, which is in that minute that the president is talking. And it kind of shows, it highlights a few categories of what jobs and fairness and healthcare. And you can also see which states of the US are talking about that right at the time that the president is talking about that. So it's a wonderful tool to analyze, to see what people are, what is resonating with people right at that time. Okay, so now we've seen some examples of study of society, and now the question is, can Twitter actually impact society? And the role of Twitter in protests and movements and revolutions across the world has been widely studied, and I'm not going to harp around here, but I do want to present one quote, which was by the Prime Minister of Turkey, said during the Turkey protests, which is a negative quote, but highlights the threat that dictators and others face from Twitter and social media in general. When Typhoon Haiyan struck, there were tweets with the word help in 22 different languages, and this visualization kind of shows that people on social media are interested in helping whenever they can. And I'm running out of time, but this is also a couple of studies in healthcare on how Twitter can be used as a social support mechanism, which traditionally you would go to face-to-face meetings if you're engaged in, say, weight loss or other interventions. But now you can use social media as a cheaper proxy or in addition to face-to-face support meetings. And the dynamics were very interesting, that users first came to Twitter to do something else, and they found that, oh, people are tweeting about what they ate or what they exercised, and then became part of that community themselves, helping others who were new to the platform. Role in governance, again, I'm running out of time, but the Boston, just a few examples. Boston Police Department used Twitter to send out updates on the manhunt. This is very interesting. President of Panama actually tweeted a picture saying sophisticated missile equipment has been found in some ships in the Panama Canal leading to North Korea, as an example of how the president is informing the rest of the world. And there are millions of such examples. But my favorite one is this, of a tweet where that's pretty much it. I and everyone else at Twitter firmly believe that human connection and open data can bring about a positive change in society. Thank you.
So next up is Eitan Adar, and he'll be talking about measures and models of the world.
Great, so thank you. Hi, everyone. I'm very happy that someone has already brought up the Google flu trend thing. I was curious how long it would be till someone brought it up, but I'm glad it came up in the last session. I want to make one argument in my talk, which is that I think the perceived failure of things like that is in large part a failure to manage expectations as much as a failure in science. And I want to do this by making maybe a provocative argument, perhaps not for some of you, that big data is largely about predictive modeling, and our understanding of predictive modeling and why it emerges as or why it's incentivized in certain corporations, or why it's necessary as a property of the data is kind of poorly understood, which I think has led to sort of a negative reaction in the press, and even within the scientific community, sort of a lack of understanding. So I do want to talk about some of the incentives that drive us to use big data for predictive modeling, as well as the forms of the data, specifically its non-reactive form, that force us to basically use it in a certain way. And understanding science or understanding society, the way we do that, the key to that is basically understanding the nature of the data that we're using. So the thing that I want to talk today about is the mapping between big data and sort of how we go from that to understanding of society. For the purpose of this talk, I want to emphasize understanding models as a form of understanding. And more specifically, I want to talk about two different kinds of models. So this may be a little bit philosophical, but I do want to make this point because I think it's an important one, which is that there are many different ways to think about the world. And usually when we talk about modeling the world, we have some input signal X that's being processed by nature or some society or some process, and then we have some output Y. And the two ways that people focus on understanding this is one, which is explanatory modeling, where basically I care specifically about how nature is acting on different kinds of things, so how the social processes are working and so on. So if I want to understand how brand trust is impacting purchasing behavior, I really need to get into the lower levels, the understanding of how that process is working. And the key features often of that in the community are that it's theoretically motivated, interpretable, and controlled. In contrast, we have things like predictive modeling, where basically we say, I don't care how things work inside. I'm just going to find leading indicators for things that I care about. So, for example, we're perfectly happy to know that sales of mosquito spray are basically predictive of sales of sunscreen. Okay, it's not a causal relationship. There's no causal here. but we're happy to know that, and it's because those two things happen to happen during summer. Okay? And so if we find that one is a leading indicator, we have a perfectly good predictive model. The argument then is that good predictive models are not necessarily good explanatory models. And while I say this to you, and some of you may understand it, this is not broadly understood, I think, by the community. And I think this is a big problem for how we treat big data. And even by the people who do understand it, we sort of then have arguments about the roles of different people within the modeling space and how we choose to pursue these things. So the first quote, the only useful function of a statistician is to make predictions, and the second one is that somehow prediction is about management, whereas explanation is about science and truth. Okay? And I think this is kind of an unfortunate view, which has led us to divide the space into predictive versus explanatory, or business versus science. Okay? And I think this is kind of limiting to the way we can use big data effectively. I want to give you two pieces of hard truth, which is in part that big data is somewhat on the predictive side, but that's not necessarily a bad thing. So while big data could be used to build explanatory models, the truth is that understanding in this way the explanatory requires experimentation, and companies that control the platforms for building experiments and evaluating the data basically have no interest in it. Okay? They're focusing on profit, and it's not really in their interest to focus on deep explanations. They really need to understand how to make predictions and be able to move on those. Okay? So big data, broadly, I'm going to generalize, is that kind of work will veer towards the predictive side. Now, you can sort of be disappointed about this and can do things about it. So in Michigan, for example, we actually have a big project. Google has funded us to basically instrument the web browsers and the phones of tens of thousands of users to collect social media behavior. And this is not cheap, it's not easy, and it's not easy to get the money for it, but luckily Google has funded us, and we're using sort of a population, very large athletic population, athletic fan population. I shouldn't be talking about this here, should I? We're using the fans basically as a pool. The second piece that I want to mention is that explanatory models really require interpretability, and that's hard to achieve when we have lots of data. So when we have crazy amounts of features, indicators, or whatnot, it's really hard to build things that we can evaluate, because we have to do lots of data reduction. Okay. So this is kind of the view of the world as it is today. What I want to push for is that this is something that we should be striving for. That any experiment can be placed somewhere on this spectrum, and experiments can be used in one direction or the other for enhancing predictive or enhancing explanatory things. The way we need to do that is basically to move out of this view that the only way to evaluate big data is how much data we have. I think quantifying it is kind of fun but useless, and the predictive power is interesting but should not be the only thing that we care about. And this has been talked about somewhat in the statistical community, sort of how to leverage predictive models for explanatory purposes, and I think this is key, and I'll come back to this a little bit later, but just at a high level, predictive models are a nice way to test the relevance of our explanatory models. They're a nice way of comparing models. They're a nice way of operationalizing new features that we don't have a sense of in the explanation space. They allow us to build new theories and enhance theoretical models. So before I really dive into this in a little bit more detail, I want to talk about a specific aspect of the data that I think is crucial here, which is that I think in large part it's non-reactive, and I'll explain what that means in a second, and I think that's the biggest plus and the biggest minus of the kind of data that we have when we talk about big data traditionally. So non-reactive measures are basically this. We're measuring without asking. We're using observed behavior, things like accretion and erosion, the digital footprints that people make in their everyday behavior and their everyday lives, as a mechanism for sort of understanding something. And we try to isolate those behaviors that we think are tied to the things that we actually want to observe. So let me give you a specific example. This is one where we have a traditional way of measuring it, and we can also talk about the big data, the Twitter kind of way of measuring it. So can you feel the earthquake? So in 2011, there was this big earthquake in the eastern seaboard, felt up and down the eastern coast. And the traditional way that the USGS approaches this problem to see if people can actually feel the earthquake, not just how big was it, but can you actually feel it, is they ask. Okay, so there's a self-report website. You go there, you come in. There's, for this particular incident, you can see that a lot of people felt it, 148,000. But the interesting thing is that it really takes a really, really long time for that data to come in. So you see a lot of people reporting, but it's taken on the order of hours to get that number. Okay, and you can ask the question, do people actually remember at that point when they come back? In contrast, this is a project by Gilad Lotan at SocialFlow, where basically they tracked the tweets mentioning the earthquake right after the earthquake as it was happening. Okay? And what you see is the white circle is basically the propagation of the earthquake over the coast, and the little red dots are people mentioning the earthquake. Okay? And the other colors are outside. What we see in the data is that the wave, which is actually in red, is being closely tied into people's expression of whether they're feeling the earthquake, like tweeting, I'm experiencing an earthquake, I'm running out of the building, whatever. Okay, so we see a pretty tight connection. I don't know why people do this. This always fascinates me, like leave the building first and then tweet. But people are tweeting as it's happening, which I think is kind of interesting. And so this is the location of people tweeting, as well as the propagation of the actual wave. Okay, this idea of using non-reactive data, sort of observing what people are talking about, the production, is not really a new idea. The real-time aspect is kind of new and interesting, but I think we've been doing this kind of stuff for a really, really long time. So let me give you a couple of small data examples, which I think are kind of cool. Scientists said, I want to measure how scary a particular story is. Okay? So what's a non-reactive way of doing this? A non-reactive way of doing this is looking at how tightly children pack around the fire while hearing the story. Okay? Tighter it is, the more scary the story is. Okay? How do we know how popular a piece is at the museum? We look at how often we have to replace the floor tiles in front of that piece. Okay? How do we know how excited Canadians are about a hockey game? We look at how often they flush the toilet. Okay? So this is the blue line is basically water consumption during the hockey game, the Olympic hockey game where Canada was playing. The green line is the ordinary example, the ordinary behavior. But we can tell sort of where the fascinating bits were. Nobody was going to the bathroom. Okay? Here's a much more modern example. Let's say I want to know how a specific Walmart store is doing, and I don't have access to that data. What I could do is use satellite imagery and see how many cars are parked in the parking lot. Okay? It's kind of a neat non-reactive measure. Not asking anyone, I'm just looking at satellite images and figuring that out. Okay. The thing that I want to push, though, is that while big data somewhat creates the opportunity for us to be creative, it basically is forcing us to be creative. There's no choice here, right? We're limited in what we can do, and so our ability to repurpose and combine the data is somewhat constrained. Okay, so this is an example from my own projects. Fukushima, the nuclear meltdown in Japan after the earthquake, constantly there was more nuclear material being dumped into the water, and we sort of wanted to understand how scary people found this experience, so how scared were people by this constant dumping. And so we looked at the number of mentions of the word scary or scared in relation to Fukushima or nuclear and so on Twitter over time, and we see these peaks as the press is reporting certain things. Now, this is a nice indicator, but it's not the only one. Okay? There's other kinds of data that we can pull, and we can do much better if we think about those ways, about the availability of data and are creative about it. So one of the things that we pulled out was the purchasing behavior around potassium iodide. Okay? So people are really scared about getting some radiation exposure. They think they're going to get cancer. The reaction is to buy potassium iodide, which is a quick treatment. And so we looked at the purchasing behavior on eBay. Okay? So the price per milligram over time for potassium iodide. Okay? And this is a secondary measure that we can also use in combination with a scary and scared Twitter measure, which gives us a much better triangulation about what's going on. Okay? So we sort of need to be able to tie in all these different things because they're all noisy on their own, but together maybe we can derive a better signal. I'll skip the rest of this for now. So the other thing that I wanted to briefly mention is a mechanism for bridging back into the explanatory space when we have no real theoretical models for how things work. One of the studies that I'm a part of, this is work with Facebook, is basically how memes not only diffuse but actually evolve. And we have these kind of vague ideas about memes should be like genes, but the theoretical models are sort of weak. Okay? We don't really understand how this works. And so this is a particular visualization of a meme on Facebook. We studied hundreds of thousands of memes. This is a meme that was no one should die because they cannot afford healthcare. People were copying and pasting this into their status update. The different colors in the visualization are different variants of it. So these are different variants of the same meme. Everything from no one should die because they cannot afford healthcare at the top to no one should go broke because government taxes and spends. I'm sure you can imagine which ones are the Democratic and Republican variants. We have access to this data, which is kind of fun. Funny stuff in the middle, go thirsty because they cannot afford wine, and zombie attacks and so on. Okay, the funny part is funny, but what I do want to bring up is that we were actually able to use this to come up with a nice model that actually explained what was going on in the world. So we found that a Yule model was basically something that explains, so with some probability p, we're going to generate the same variant. With 1 minus p, we're going to create a new variant. And this basically explained what we were observing, and no one had done that up to this point. There was no model of sort of mean mutation that we're aware of that sort of saw this in the large. Okay. Another example is when we can sort of triangulate based on things going on in the world where there are different communities that are sort of isolating themselves. We studied fragmentation of Democratic, Republican, and Tea Party candidates during the 2008 election. This is follower-followee relationships on Twitter. You can see, even from the visualization, but I'll tell you that it's true, Republican candidates were quite clustered and dense in terms of network structure. They all link to each other, they all talk to each other. Democratic candidates less so. Tea Party candidates were much closer to the Republican side. The language that these people used was also very similar. So we were able to study the language that was being used. And then we were able to compare and contrast, and so we found Republicans being dense in terms of structure and also in terms of the topics and the way they talked about the topics. Basically, the point here is that we were able to isolate these different communities within this network and sort of form an understanding based on that isolation. Okay, to wrap up, I think where it works is this. Where it works is that once we acknowledge where things are explanatory, predictive, or forecasting. Where it works is where we acknowledge that we need multiple of everything, multiple indices, theories, hypotheses, and instruments. So for example, in a study of how people revisit websites, I had a huge amount of data. This was work with Microsoft, 50,000 websites, millions and millions of people. We sliced and diced the data in different ways. We said, this is how people revisit the website. But in addition, we basically had survey instruments. We went and asked people, we went and interviewed, and so on. And we were able to get not only an appreciation, but a much deeper understanding of the behavior beyond what the query logs were telling us. Okay. I think it works where there's theoretical insight and motivation. I think it works where we understand and embrace the fact that there's noise in the system. And that basically we should treat this as there is no noise, okay? Everything is signal of a sort, and it just depends on what we're measuring. Now, there's lots of limitations to this kind of data, the people, and so on. There's recalibration that's necessary and limited interpretability. The point is, I can create these limitation slides for any kind of method, not just big data predictive modeling. And we really can't expect perfection from every data source. I think, though, that understanding this makes it so that big data is actually great for a lot of things. Not everything, and not to use blindly. And really, once we do understand that, we can fit it within the context of methods that we know about. And I think there's a lot of work that needs to be done, but a lot of nice applied immediate work that can be done about how to integrate these methods into our toolbox. Okay, thank you.
Thanks, Eitan. Next up, we have Tara talking about how Nationwide uses data to understand things.
So I don't have slides, and after I got here and saw that it was going to be behind me, I'm really happy because I get distracted by squirrels, and that would be a squirrel all the entire time I was talking. So when I was first asked to do this, I thought, wow, insurance companies have never been accused of actually having a positive impact on society, so what am I going to talk about? But what Nationwide does is we keep promises, right? We promise to protect what matters most to our members. And with having access to a wide variety of information and the technology to be able to analyze that, we have a unique opportunity to keep those promises even better and live up to those promises. So we're seeing really 3 design patterns that provide us with the ability to have value creation out of this type of data. It includes linking and integrating wide varieties of information, data visualization, and then and what we're referring to is speed to action. So traditional structured tabular relational information makes up about 10% of our enterprise data, while social media, images, voice, unstructured text, and machine data makes up about 90% of our data. And so given that the traditional data warehouse kinds of relational information runs on relational databases and enterprise class data warehouse systems, and the big data, the unstructured information runs on, big data platforms such as Hadoop. When we want to look at that data in context of each other, we're faced with the quandary of, do we try to shove the 90% into a platform that it doesn't work on, or do we try to move the 10% to the 90%? So we're kind of going through that right now at Nationwide, and we're using IBM products. So I want to go into my first design pattern, which is integrating the wide varieties of information together to understand our members and their behavior using a typical structured information scenario. So if I look at policy or account information, I can see the number of sales that we had last month. If I combine that information with customer data, I can see that members who were less than 20 years old made more purchases last month than members who were older than 40 years old. If I then combine that with location information, I could find that members who were less than 30 years old in Ohio purchased 2 times the amount of volume than members who were the same demographic but in Texas, right? And then if I add activity data, such as customer interaction information, clicking on the website, that sort of thing, we can find that people who use mobile devices to respond to display ads and then subsequently make a purchase are more likely to enroll in such things as paperless billing. Right? So that's a very simple example using typical structured information. Now, using that same kind of scenario, but with more complex data, I'm going to start out with telematics. So does everybody know what telematics data is? Okay. So it's devices you put in your car. It's usage-based insurance. So you put a device in your car, and it tells us how you drive. Okay. So, and we don't force you to do it. So if I just look at the telematics information, the basic telematics information, I can tell that your patterns of deceleration and acceleration when you drive, right? And I may find that Tara fast accelerates a lot. And so I might find her as being a high risk. And so therefore, I don't give her a discount on her insurance. Then if I combine all of the telematics information with our claims data, I may find that acceleration and deceleration have really nothing to do with the number of claims that we get. If I combine that with customer information, I might be able to find that customers who enroll in our usage-based insurance program actually show more loyalty to Nationwide. I might find that. I may find that they use self-service options on our website more frequently because they're savvy enough to stick a device in their car. If I actually get the GPS information on the telematics stream, I may be able to discern their natural driving patterns every day from home to work and that sort of thing. And then when are the times of day that they're actually driving, and so I can maybe actually do more radio ads during those times. If I combine this with social media, I might find that my 16-year-old daughter is tweeting while she's driving. That's kind of creepy, but maybe I don't tell my parents, my customers who are parents, that information. But maybe I offer them a service for their 16-year-old drivers on the dangers of doing social media and that sort of thing while they're driving, obviously. And then if I combine that with traffic information and map information, I may be able to actually offer my customers, my members, safer driving routes to work. I may be able to give them advance notice of accidents that are occurring in their normal routes. So there's a unique opportunity for me to provide services to my members that will improve their daily lives. So then I want to go into how does visualization used in these similar situations. Obviously, and I think there's a panel on visualization today, a discussion on that. But the data has gotten so big that the analyst can't actually discern information or discern patterns out of it, just normal crosstab or even, pie charts and that sort of thing anymore. We need cartography and different types of animation and so forth to discern these patterns. And an example that we have our customer analytics team teamed up with our fraud unit. And fraud is obviously really bad for society in insurance. I mean, it causes everybody's rates to go up. There's a human factor of people actually being involved in accidents that are staged and that sort of thing, innocent bystanders. And so this is a really bad thing that we want to prevent, right? And it happens a lot. So our customer analytics team was able to take fraud information, the indicators of when we actually had detected fraud and stopped payment on a claim or whatever, and overlaid that on using map information and time. And we're able to show that in a geographic location that fraud in those zip codes actually went down. However, we continued to pay claims to locations where we had previously detected fraud. So that was previously unknown to our fraud unit, right? And obviously we don't want to do that. And so the normal reaction, this kind of brings me to my third design pattern, which is speed to action. The normal reaction to that is, okay, well, I'll just go add indicators in my database where to keep track of that there was fraud. Well, do I put it on the primary person on the policy? Do I put it on a party record? Do I put it on the location? Is it the mailing address of the person, or is it the risk location of the car or the home or so forth? Where do I put that? So that's not the way you handle this today. You actually must embed that analytical method within the business process. So at the time I'm going to bind a policy, or at the time I'm going to issue a claim, I want to execute that analytical method that determines all of these entities that might be involved in fraud, and then alert the CSR or the agent or whomever that this is a potential fraud situation, so we need to actually investigate this a little bit further before we bind the policy or before we actually go any further with the claim to stop that action from occurring. Another scenario around speed to action is in our call center. So this is actually a R&D effort that we have going on right now with my team. Again, we want to live up to our promises to our members, and one of the promises we make is when you call our call center and we can't solve your problem immediately, we'll call you back. And sometimes if we think we don't call you back. And so one of the things we're looking into the call data and doing speech to text and then mining the text is how often do we say we're going to call you back, and then looking at our structured information around contact history to say, was there actually a contact with that customer following that conversation? And then, so we're going to determine if this is a viable scenario that is occurring. If it is, what we want to be able to do is actually, during the call, when we detect that the CSR has said, I'll call you back, we can actually insert a follow-up record for them to acknowledge, to say, okay, I'm actually going to call this person back, instead of actually making them create the follow-up so that it'll remind them. We'll automatically do that by using real-time detection of that speech pattern and inserting the follow-up for them. And so that we can actually improve on them actually calling the customer back and resolving the issue. So that's really what my whole talk was about today. And I think I actually made up for time.
Thank you.
You're welcome.
Thanks, Sarah. So there are mics on either side of the aisles over here. So please feel free to come forward and ask questions. I'd like to give an opportunity for the speakers to ask them each other questions if there's any thoughts and comments. I actually had some thoughts about these slides and conversations that I just heard. So one of them was a very simple statistical concept called sampling bias. Now, if we saw the pictures of diurnal patterns and circadian rhythm patterns for every city, these were people who were tweeting. We don't know what the people who don't tweet do in terms of when they sleep and they don't sleep. So maybe there are people who in Tokyo who don't, who are up really late, but they're watching TV instead, or playing board games. They're an older population. The other set of people could be in Seattle, where it's really, really required to accelerate over a hill. It's not really risky behavior. It's just, you know, how you get over a hill with an old car.
Right.
I mean, this is my excuse for why I would accelerate really fast, right? And then you would have similar explanations for different contexts, and I think Eitan brought up context as well.
Right.
So is this concept of sampling bias, when you're trying to come up with an understanding of society, is there a way to even figure out that, yes, we're not looking at the entire pond, we're just looking at a site, one small part of it?
I can go first. Yeah, you're absolutely right. You cannot measure data that you don't have. Eitan brought about a very good point that you have these multiple signals from a variety of different contexts, from a variety of different platforms, and that's what big data is about. You know, it's about fusing these different types of data from different platforms, from different sourcing mechanisms, and using that to come up with an observation or a conclusion. Yes, we don't know what people who are not tweeting about how late they are, but that's kind of the responsibility of, you know, anyone who's presenting the data to make those disclaimers and to make that widely known that that is the case. Now, big data and just helps overall, and just that the bigness of the data helps a little bit there, as long as, you know, you're verified that those sampling biases have been kind of smoothed over. But you're absolutely right. This is not just understanding of society, but even at a finer granularity, when we slice the data amongst various dimensions or to narrower sections, then you see these sampling biases much more.
My whole point around my talk around integrating the different types of data is because context does matter. I fast accelerate because I'm getting on the freeway, you know, and if I combine the telematics data with the map data and the traffic data, we would see that Tara is fast accelerating every morning during rush hour traffic when she's getting on the freeway, which is a totally different scenario, and I would rate her a totally different way if I knew that information. And so, so that's why, to me, it's really important, at least in my business, that you don't look at big data out of context with what you already know about your members. And that structured information, that's why it's so important to bring it together when determining what problem you're trying to solve, right? And I think that's really important, that you're not starting with the data, you're starting with the problem that you want to solve. And so a lot of, I think, people that love data or, you know, statisticians and all, we want to jump right into that, and then we'll make the data fit whatever problem's out there, right? We can. You can do that. But you really want to start with the problem that you're trying to solve and then go into the data and not jump straight into making assumptions about it.
I saw someone say that big N doesn't mean all N, right? So big data doesn't mean all data. We certainly don't have the perspective of every human being, and not every human being is using Twitter, although it's getting close. You know, I think sampling bias is a hard problem, but it's a hard problem independent of the method. And the way it's traditionally addressed is you sort of can make arguments about the population that you are sampling versus the population that you're not sampling from. And it may be harder to get a sense of that with things like Twitter, and it's certainly harder, a harder problem the further and further you get from the actual measure of interest. So whether someone is awake, like you would want to ask them, are you awake or not, and like have them respond yes or no. Wake them up, right? Ring a bell and say, are you awake now? Like my kids do. You know, I think this is a problem with the fact that we're getting further away from the measure of interest, that can potentially introduce additional bias. But we know that it exists, and we try to reason about how much it exists in the data that we're studying and the methods that we're using, and I think that's the best we can do right now. I don't know of any easy way to solve this. Certainly just have to acknowledge it and integrate models of the bias into our models.
Cool. Thanks. Let's go on to the next question.
Great. Well, so this is following on the same theme, which I think is kind of very interesting to follow the comments. So I'm Nick Mader. I'm going to be talking tomorrow about social science applications. And what is of concern to a relatively traditional social scientist is the representativeness of a given population. And so when we have big data, so Eitan and Pankaj had both mentioned this. When you have big data, you can wash out noise. But you can't wash out bias, unless different instruments, have bias on different sides. And so, I imagine even when Twitter reaches everybody, and we have a representative set of people who may tweet, that the content which is delivered on Twitter is also selective because it's what I will consciously offer, or it is events that are of such an extreme nature that I feel compelled to tweet it. Maybe it's about my breakfast, or maybe it's about an earthquake. So rather than just like standing up and making the easy kind of commentary of like, oh well, it's not representative. What I wanted to kind of open up as a question to you guys is, what models do you see for getting complementary? Like the census is one example where we actively solicit from a representative population. I just wanted to check in with you guys. What means do you see for getting the equivalent of active solicitation or representative solicitation? And is that necessarily old conventional models, or do you see technology as a way to fill in what would be representative?
This is kind of touching upon what we were just discussing. To acknowledge the presence of these biases, I think the traditional methods that, as far as I understand, social scientists have used, like questionnaires and asking questions, are wonderful methods to do randomized controlled studies to verify any observations that you may have made from big data. So for example, we could look at past tweets and say, okay, people are waking up at these times, but, and then we follow up with actual questionnaires to verify in a completely randomized study that is indeed true, because correlations are everywhere in the big data that we may analyze in the past. Was that kind of question? Okay.
I don't think there's an easy fix, as I said. I think going out and doing other kinds of sampling. So we leverage ICPSR, which is the institute. I forgot what it stands for. They're kind of a large survey organization within the University of Michigan, within the Institute of Social Research. So we use those kinds of instruments as a mechanism for validating some of the stuff. So with the M Together project, where we're giving millions of athletics fans access to this technology that's going to track them and report back to us, we're going to be using other things to validate whether we're getting a reasonable sample. And we have survey instruments that we're integrating into the thing, where we're asking demographics and we're comparing them to what we know about groups in general and so on. We try to do the best we can, and I think doing the best we can requires using some of the more conventional and understood instruments and methods. So I don't see those things going away. I think they're a really nice way of enhancing what we have with big data.
I can actually jump in a little bit if I can mention. So there are lots of different new technology options in terms of one solution to, instead of actively soliciting things or soliciting information, is to make it easier for you to express that information in the first place. So one example would be there are mood tracking apps out there, or other mood tracking services, which literally text you once an hour saying, how are you feeling? This is great because all you need to do is respond saying smiley face or sad face. This would be extremely hard for a psychologist to otherwise say, here's a survey, if you have bipolar disorder, here's a really long 20-page survey that you have to take. Instead of that, you have one person just texting. If this is a teenager, this is normal conditioning anyway in terms of how the behavior is. So just using different technology methods and interfaces to make it easier for you to express that information might be a viable solution over here. So yeah.
Actually, one more point to add is that even within our industry, just the technology industry, we heavily use human evaluation methods to verify any conclusions that we might be tempted to make from models. So we do want to put humans to judge, to rate the output of algorithms or models. And I see an analog in terms of making larger conclusions about society or sections of society.
Cool. And just to add in one answer that I really like from Tara is that there are ways that you can encourage people to actively offer their data. So if it can reduce my premiums, then I will offer a stream of my driving data. I think Joel had given an example last night of the Mercedes example where I can offer my consumer data. Like if it allows companies to reach me better.
Great.
Thanks for the discussion.
Thanks. Next question.
Hi, I'm Nader Afzalan from the University of Colorado. I have a specific question regarding Twitter from Pankage. So what type of background information do you collect from your users? Do you know who are they? What is their educational background, social demography? Do you collect those types of information as well?
Yeah, in order to sign up for Twitter, you just need your email address and choose a strong enough password. And then you start following people and then you start tweeting. So we don't ask people explicitly, but we do, again, using the information that users have provided, like what are they tweeting, which is public information. We build predictive models of what their interests are. We try to personalize each and every product feature based on what we know about the user or what we can find about the user. And that's just kind of keeping in mind our desire to make the service the most useful to each user, which could be separate from you, separate for you and me. And one example is, I built the follow recommendation system at Twitter, which is just who are the people that you might want to follow, and that will be different for you versus for me, and would be based on your existing networks, for example, or your interests.
Hi. So we've been talking a bit about self-selection bias, but I think there's another bias we need to talk about, which is self-representation bias. What are people presenting when they use social media? For example, right now I'd be happy to check in here at the College of Law at 11 o'clock in the morning and look like a scholarly person, very dedicated to my work. If I was in a bar right now, I wouldn't necessarily want to check in, let people know what I'm doing at 11 o'clock in the morning. So there are, there's a presentation of what people present to other people. There was a classic book written in 1959 by a sociologist named Irving Goffman called The Presentation of Self in Everyday Life. And he talked about, used the theater as a metaphor, and he talked about front stage versus backstage behaviors. That there are front stage behaviors we want other people to view, and backstage behaviors we want to keep private. So I guess I'm just wondering what your thoughts are on that. I mean, is our backstage behavior shrinking relative to the front stage behavior given all the social media? Are we going to basically voluntarily give up, backstage behavior and private behavior? And, are we moving towards a society of oversharing?
I don't know how much you can share of your backstage behavior in 140 characters, but yeah, I think that's a huge bias. I don't know if it's shrinking. I think people are much more forthcoming about certain things that we would have considered private before, but it's still act, right? Like there are things that we retain as backstage behavior, using the Goffman terminology, that we don't know what that looks like today and what that might look like a few years down the road. But certainly, like the social norms around what you should tweet or should put as a status update, those things mediate sort of what it is that you're going to say. So the norms, how different you want to be. We see this, so I used to study blogs, for example, and with blogging behavior, people didn't want to say the same thing as all their neighbors. Like there was a disincentive for doing that. You wanted to say something new and different. So you would find topics to talk about that were new and different from your neighbors, and that's a bias in itself, right? Like you're trying to shine or look different. in other contexts, you may want to look the same. I don't know. So yes, those things, sort of how you represent yourself, how you act through the intermediary of the social media system, I think will bias sort of what we observe. Absolutely.
So it doesn't really apply to our member scenarios, but one of the things that we worked on in my team was we use Yammer internally at Nationwide for our agents and staff to collaborate, right? And we were analyzing the Yammer feeds for sentiment of our employees and so forth. What we were trying to discern is engagement of our workforce through Yammer, which was really interesting. But what we found is when we tried to use publicly available sentiment dictionaries, and they were less accurate than if we built our own dictionary, because the words that our staff used internally on an employee social media site were quite different than what the public uses on general open social media. So that was one indicator that obviously in the workplace, at least most of the time, our HR people delete the ones that are not appropriate for work. It's surprising to me that people would post certain things at work. But for the most part, behavior and the things that you talk about on a collaboration site in our social media site inside of work is quite different than your public persona.
Yeah, I wanted to make 2 points in response to your question. One is that, the whole thing about doing a status update in a public, semi-public forum is new. It is new to society, right? And we see that behavior even within Twitter when we do some longitudinal studies of users as they're joining Twitter to when they're more mature users, that their behavior, their pattern of what they're tweeting and when they're tweeting changes over time. However, it is the case, at least as what we find from our studies, is that more people, as far as we can tell, are bringing their true selves to the platform. Just whether it's through smartphones or the rise of the internet, but people.
May I ask how you can tell that? How are people bringing their true selves to the social media?
These are, again, validated against relatively small-scale surveys that we do. And we also have user research teams who go and talk to different users in different cultures, because that's what we need for customizing our product across different nations. Yeah, and the second point I wanted to make was that some of these things are actually detectable by technology. And I think our models will get better over time to figure out that, hey, if this person is really only tweeting about conferences and their professional lives. And we can today. They're not perfect models today, but they are going to get better. And we are working on that. We as a whole community are working on improving our models to be able to kind of discern those different types of user behavior.
I was just reminded one last thing. I was just reminded that there's a little bit of study in this area. I think there's some qualitative work where people are interviewed to sort of understand longitudinally how their behavior has changed. There's also been work from the psychology community. So Sam Gosling in Texas, UT Austin maybe, has done personality inventories, compared behavior on Facebook versus sort of validated instruments. And so there's some ability to correlate some of those things, but yeah.
So I'm wondering, a recurring topic of discussion, I think, among both media scholars and democracy scholars is the phenomenon of what seems to be increasingly people speaking and interacting online and maybe offline only with people whose beliefs and values kind of reinforce their own. And I'm wondering both descriptively whether any effort's been made to sort of figure out, looking at people's, Twitter followers and followings, how homogeneous or heterogeneous those networks are along different models. And then I guess related to that, I'm wondering, because occasionally I will get the email from Twitter that says, I see that you're following A, B, and C. Would you like to follow D, who seems to be interested in the same things, whatever. I wonder if Twitter's considered having, maybe a branded kind of mix-it-up tweet. I see you're following Rachel Maddow. Would you think about following Bill O'Reilly? Just to see if you could get people to voluntarily seed their threads with multiple points of view.
Yeah, no, that's a great point. And, this kind of the filter bubble, as it's been called, of giving more of what you already have. Just as a background, giving more or giving similar things to what you already have works great in aggregate. Because from the point of view of a system like Twitter or Facebook or Google, because most people are looking for similar types of information of what they already have. So I can speak for Twitter. In our recommendation systems, we do inject quote-unquote random things, which may not be very similar to what you're already doing. But I cannot claim that those are completely random, right? Those are completely dissimilar to what you already have. Those have been injected because maybe they're just worldwide popular, right? There's a certain objective function that we are kind of optimizing over the set of all our users. It is a problem, and I think most online platforms recognize that is a problem. And that problem exists for, again, different types of users on these platforms to different extents. There's a value system that we are expressing here that, hey, we should expose you to other types of content and users that are dissimilar to what you already interact with. But there's also a benefit to the system to be doing that. And there are, optimization strategies, some called explore, exploit, which you kind of don't know enough. I may not know enough about you, and I will just give you some things or give the population some things and see how they react. And just in the process of doing that, we are essentially giving a random sample of what exists out there so that they expose you to other things. Net though, what we have observed is that people like to densify their current thinking. And so this polarization is very real. I don't know whether it is how people are in real life as well. I mean, again, I'm speaking in aggregate rather than specifics. And I think Eitan showed some study about the clustering of networks in different parties.
So that was within candidates, but we've certainly seen this with just regular people. So Sean Munson at the University of Washington now studies techniques to basically, he calls it the rebalance project. Like if you read a Republican-leaning article, it'll offer you a Democratic one, and there's sort of an icon which is showing you how balanced you are. But I think that only works for when it's a best self argument, right? Like I want to be a balanced person, and if I want to be a balanced person, then I will respond positively to getting articles that are balanced. If I don't want to be a balanced person, then yeah, you're giving me this stuff, and it'll just annoy me or push me in the other, in the direction I was already leaning. And so I think there's a lot of care that needs to be taken in how we deal with the filter bubble. I think people are happiest when you give them things that they like, and understanding what they like, I think, is the hard part that we're struggling with. The easiest thing to figure out that they like is more things like what they're doing already, and it's harder to tease out the broader image that they have of themselves and how you might satisfy that.
Just a quick follow-up observation. I've read, and I think this makes sense given my own experience, that people are most receptive to things that are outside their comfort zone if they're presented to them by people within their comfort zone. So, the Center for American Progress, which is on the left, has actually started an interesting project where every week you can subscribe to a newsletter called The 3 Best Things We've Read This Week, written by conservatives. And that's probably getting written more because the people getting it trust the people who are providing these recommendations to send them stuff worth reading.
We see this in the study of Twitter networks, by the way, that there are people who are really good at the translation work that are basically able to frame arguments in a certain way and are perhaps trusted in a way that allows the message, the meme, or whatever to move from one part of the network to the other.
Thanks.
Morning. I work for the government, and we have academics, and we have business, and we have communication. You know, there's a digital or a data divide, I guess, between the public sector and the private sector, that there's big data, but it's not always accessible to the government people. And I'm wondering if you have any thoughts about that government works at the speed of government, and business works at the speed of business, and there's a real differential in terms of the information we have access to make public policy decisions. And I'm just wondering what the relationship, I guess, is, especially between Twitter, and I just have kind of a quick, real simple question. When somebody tweets something bad, I mean, is there like a relationship between you and the police or the FBI or something like that?
Sorry, say that again. If someone tweets something bad,
like,
then is there a relationship between us, Twitter,
Yeah.
and the FBI? No, absolutely nothing.
really?
Yeah, in fact, just the other day, somebody had this horrible tweet saying that if this tweet was retweeted 100 times, then I will shoot someone with a picture of the gun. I mean, this was horrible, and people were retweeting that tweet. But that person was arrested, and it's. I mean, we're a very small company, and it's not. Our CEO says that it's not our business to kind of do matchmaking between the kinds of tweets and the kinds of people who might be interested in those tweets outside the Twitter platform itself. To answer your first question about accessibility to data, it is in general a problem when data is with private companies. In the case of Twitter, it's a slightly less of a problem, I would like to say, because the tweets are public, and we publish a fraction of all the tweets are available to everyone, and that's how a lot of research has been done by third parties outside Twitter. You can also look for certain sets of keywords and just get tweets containing those keywords or other criteria from Twitter. It is harder, in terms of search queries on Google or even Facebook status updates that are not public. But still, as Twitter, we do not publish the entire, what we call as the fire hose of tweets, because we don't want to. It is a problem, but at least for Twitter, I can say that fascinating studies have been done on that fraction of the 500 million tweets that are sent every day. And in addition, actually, we started a data grants program where we are working directly. We will be working directly with academic and research institutions who want Twitter data for specific purposes.
So I have two comments. I thought the NSA had access to everything, apparently.
Go ask the NSA.
Yeah. But actually, with Nationwide, it doesn't have anything to do really with big data, but more with information security and fraud. We have a direct relationship with the FBI.
Mm-hmm.
So when we discover fraud rings and stuff like that, we report it. And then with regard to information risk and security, anything that we suspect is subversive, we will report it to the FBI.
Working a little bit with the government, just to add, I think some of it is not the ability to it's not that they just can't, there's no infrastructural support for handling the data that's coming. And Twitter gave away a copy of its collection, I don't know how many years ago, to the Library of Congress, and a bunch of us are sitting still waiting for the Library of Congress to do something with it so that we can actually use it. There was a lot of excitement at the time, but there's just no infrastructural support, and the kinds of servers that exist at these companies are just not existent in the government in a way that allows any government agency or any academic to sort of make use of them. I think that's a huge problem as well.
We use census data, and it's Census Bureau is always at risk of getting its budget cut, and the data that we get it every year now, but it's 5 years worth of information and has margin of errors that are humongous, sometimes larger than the results. And it's, you know, it's just sort of frustrating from the perspective of doing your work, knowing there's information out there and people have it, but then to do the work to put ideas into people's minds for policy, that it's based on old stuff, that a lot of it is just taking it and kind of thinking it out and making some sort of suggestion. So, thank you.
Great, thanks. And thank you for your wonderful questions, and thanks to the panel for participating. We're going to take a 15-minute break, and Kate Crawford will be speaking next at 11:30. It's a 10-minute break, sorry. Yeah.